Alright, March the 29th through April the 2nd, we're going to be looking at lesson 30. Lesson 30 says linear systems and 3 variables. Alright, so let's go ahead and look at exercise 1 through 3. Determine the value of x and y in the following system of equations. Alright, so we do have a system of equations here. You should be familiar with how to solve those, but let's go ahead and look at this. I would suggest for one that you go ahead and solve for y in one of the equations, and I would suggest you make it this equation. So 2x plus y is equal to 3. I'm going to subtract the 2x, and I get y is equal to 3 minus 2x. Since I know what y is equal to, then I can plug it in for y here. Alright, so I get 2x plus 3 times 3 minus 2x is equal to 7. Let's go ahead and solve that. 2x plus 9 minus 6x equals 7. So I have negative 4x plus 9 equals 7. Subtract 9. I get negative 4x equals negative 2. So then divide by negative 4, and x equals 2/4 or 1/2. Now that I know what x is equal to, I can go ahead and plug that back in. It does not matter what equation you plug it back into. So I would plug it back into this one. So 2 times 1/2 is 1, plus y is equal to 3. Subtract your 1, and y is equal to 2. Go ahead and let's look at this one. Once again, I'm going to solve for y in the second equation. So I'm going to add 2x, and I get y is equal to 2x plus 2. Alright, so since I know what y is equal to, I can now plug it back into the first equation. So 5x minus 2 times 2x plus 2 is equal to 4. Distribute 5x minus 4x minus 4 is equal to 4. I get x is equal to, I'm going to add 4 to both sides, x is equal to 8. Alright, since I know what x is equal to, go ahead and plug back in. Negative 2 times 8 plus y is equal to 2. So negative 16 plus y is equal to 2. Add 16 to both sides, and y would be equal to 18. Okay? So really quick review of how to solve systems of equations. A scientist wants to create 120 milliliters of a solution that is 30% acidic. To create this solution, she has access to a 20% solution and a 45% solution. How many milliliters of each solution should she combine to create the 30% solution? Alright, so we can solve this using a system of equations. We have to identify our variables. Alright, so we've got a 20% solution, so we'll let x equal the 20% solution. And we'll let y equal the 45% solution. Alright. So we're going to write one equation to represent the total amount of each solution needed. So I know that I'm going to have x amount of the 20% and y amount of the 45% to equal 120 milliliters of that solution. Then I'm going to look at the percentages. Alright? So 30% of 120. So I would multiply 120 times 0.3, and that is 36. So we can write one equation to model the acidic proportion, which is 20% solution plus 45% solution is equal to 36. So writing these two equations as a system, we can solve. Alright? So go ahead. What I would suggest you do is you can solve this for y and then plug in. You can solve it for x and then plug in. You can solve the second equation for x or y. It does not matter. There's several different ways that you can go about doing this. Alright, so let's go ahead and we'll solve for y. So y is equal to negative x plus 120. Alright, let's go ahead and plug that in. So I get 20% x plus 0.45 times negative x plus 120 is equal to 36. Alright, so we'll go ahead and simplify this. I get a negative 4500 x plus, we're going to multiply 120 times 45 hundredths, gives me 54, is equal to 36. Combine your like terms, alright, so I get a negative 0.25x plus 54 is equal to 36. I'm going to subtract 54, and I get negative 0.25x is equal to negative 18. Divide by negative 25 hundredths. Alright, so negative 18 divided by 25 hundredths negative, x would be equal to 72. Alright, which means that we would need 72 milliliters of the 20% solution. Alright? Now let's look at, and then we'll just go ahead and do this. And write that. Now to figure out my x, I'm going to plug 72 back in. And I would suggest you do it in the first one because the first one's a simple equation. So it's 72 plus y is equal to 120. Subtract your 72. And y is equal to 48. So you would need 48 milliliters of the 45% solution. Okay? Alright. Alright, so in those couple of examples, we see how to solve a system of linear equations in two variables using elimination or using substitution methods. What happens when we have three variables? Alright? So let's look at this question here. I have 2x plus 3y minus z is equal to 5. I'm going to name that my first equation. Okay? Then I have 4x minus y minus z is equal to negative 1. I'm going to name that my second equation. Then I have x plus 4y plus z is equal to 12. That is my third equation. Alright? Alright, so I would suggest that you number your equations. The reason being is once you see these steps, you're probably going to see that numbering them does help. Alright, so here's what we're going to do. We are going to eliminate one of our variables from equation number 1 and 2. Alright? And I I'm going to write out my steps. So I'm going to eliminate z in equation 1 and 2. Alright? And we're going to do that by, if you look, they're both in negative, so I can subtract those. But the thing about it is, when I subtract 1, I have to subtract everything. Alright, so let me show you what we're going to do. Subtract 4x minus y minus z equals negative 1. My parentheses should be at the very end, sorry. Alright, so when I subtract that, this is what I get. 2x minus 4x is a negative 2x. 3y minus a negative y is 4y. Negative z minus a negative z, that zeroes out, is equal to 5 minus a negative 1, which is 6. Okay? So now we have eliminated one variable. Our goal is to find two equations with two unknowns. Alright, so we eliminate z from equations 2 and 3. Alright, so now we're going to eliminate z in equations 2 and 3. Alright? So let's look at how we can do that. And this is why we're doing this, because they're both 1s. They're opposite here, so I can add those two equations together. So I've got 4x minus y minus z is equal to negative 1. And I'm going to add those equations together. Okay? Alright, so now 4x plus x is 5x. Negative y plus 4y is 3y. Negative z plus z is 0. And then negative 1 plus 12 is 11. Alright, so now I have two equations that only have two variables. Alright, so our new system of three equations in 3 variables has two equations with only two variables in it. So here's our new system. Alright, so our new system looks like this. Negative 2x plus 4y is equal to 6. 4x minus y minus z is equal to negative 1. And then 5x plus 3y is equal to 11. Alright? So now I have this new system. Alright, and like I said, notice that I have two equations that now have only two variables. Alright, so we know how to solve a system when we only have two variables. So now what we're going to do is we are going to solve for two variables. Alright? So looking at this, I have negative 2x plus 4y is equal to 6. And then I have 5x plus 3y is equal to 11. Alright, so I've shown you how to do substitution. What if we do some elimination here? So I can figure out, is there a way for me to get my x's or my y's to be the same? There is. I can make my x, I have a negative 2 and a 5. So what's something they have in common? 10. And in order for 10 to eliminate another 10, one has to be negative, one has to be positive. So I can multiply this equation by 5, and I can multiply this equation by 2, and what's going to happen is I'm going to have a negative 10 here and a positive 10 here, and that eliminates my x. Alright, so let's look at what I have. I have negative 10x plus 20y is equal to 30. And then I have 10x plus 6y is equal to 22. Alright, and I can add those two equations together. Alright? Or, I'll tell you what, something that may be simpler, no, let's go ahead and add those two equations together. Alright, so I get 26y is equal to 52. Divide by 26, and I get y is equal to 2. Alright, so since I know what y is equal to, I can now go back into one of my original equations and plug that in. So 5x plus 3 times 2 is equal to 11. 5x plus 6 is equal to 11. Subtract 6, I get 5x is equal to 5. Divide by 5, x is equal to 2. So I now know what x is, I now know what y is. So now all I have to do is go back up to one of my original equations and plug those in. I would go to the bottom one because the z is positive. It is your choice. So 2 plus 4 times 2 plus z equals 12. 2 plus 8 plus z equals 12. 10 plus z equals 12. Subtract the 10. Z is equal to 2. Alright? Did I do that right? 8, 10. Yes. Okay. So z is equal to 2. Alright? So I can write my numbers in order, and I would write them in order of x, y, z. Alright? So x is not 2, x is 1, which means I messed this one up. Sorry. So I get 9, subtract 9, and I get z is equal to 3. I thought it was weird that they all three equaled the same. Alright, so I would write these in order of x, y, z. Alright? Problems like this do take a little bit of time because you are having to go through the whole entire process. Alright, so let's look at this one. Given the system below, determine the values of R, S, and U that satisfy all three equations. Alright, so let's go ahead and look at this. Look at this. I've got a negative U and a U. So I can go ahead and add those two together. Alright, so I get R plus 3S, my U's cancel out, is equal to 12. Alright? So then I can look at this, and if I look at this one's nice. I have S minus S and U minus U, so I can add these two together. And look, I get R, those cancel, is equal to 6. So I already know what R is equal to. Alright? So now, substituting this into my first equation, I can figure things out. Alright? Substituting this into the first equation and adding it to the second gives us, so we've already added the second one together, so now let's plug in R, and that's going to give us S. So 6 plus 3s is equal to 12. Subtract, I get 3s is equal to 6. Divide by 2. S is equal to, divide by 3 and s is equal to 2. So now I know what R is, I know what S is. I can plug in. So R is 6 minus 2 minus U is equal to 2. So 4 minus U is equal to 2. Subtract 4. Negative U is equal to negative 2. Divide by negative 1. U is equal to 2. Alright, so I can write these with my R, my S, and my U. Alright. Alright, let's look at exercise 5. Find the equation of the form y is equal to ax squared plus bx plus c that satisfies the points 1, 6, 320, and negative 2, 15. Alright, so let's think about this. I know that my y coordinates are 6, 20, and 15, which means that I can set up 3 systems of equations here. Alright? We know 3 ordered pairs. Let's create those equations. I know what x is equal to. Okay? So let's set up our first equation with 6 is equal to, and then plug in 1 for x. Well, 1 squared is 1. 1 times a is a. B times 1 is b, and then plus c. Let's do the same thing for the second one. So y is equal to, so 20 is equal to, now we're going to plug in 3 for x. 3 squared is 9, so I get 9a, plus 3b plus c. Alright, then I have y is 15, so we've got 15 is equal to, negative 2 is my x, so negative 2 squared is 4a. Negative 2 times b is negative 2b plus c. So I now have a system of equations, excuse me, in 3 variables. Alright? Now, I can go ahead and use everything that I've learned to solve these. Eliminate a variable. I can eliminate c by subtracting the first and the second equation. Alright, so 6 minus 20 is negative 14 is equal to a minus 9a is a negative 8a, b minus 3b is negative 2b, and then my c's are eliminated. Alright, now I'm going to do the same thing here. So I'm going to subtract the second and third equation. And then that's going to give me 2 equations that have 2 variables. Alright, so we're going to subtract the second equation. So 20 minus 15 is 5. 9 minus 4 is 5a. 3 minus a negative 2 is 5b. And then c minus c is 0. So now I have a new system of equations. I now have 2 equations that have 2 variables. So let's go ahead and solve this one for a. Alright. So if I subtract 5b, I get 5 minus 5b is equal to 5a. Divide all of that by 5. So a would be equal to 1 minus b. Alright, now I can plug that back in here for a. So negative 14 is equal to negative 8 times 1 minus b minus 2b. Negative 14 is equal to negative 8 plus 8b minus 2b. Negative 14 is equal to negative 8 plus 6b. Alright, go ahead and add 8 to both sides. I get negative 6 is equal to 6b. Divide by 6, and b is equal to negative 1. Alright, so I now know what b is equal to. Since I know what b is equal to, I can now plug in here to find a. So I get 5 is equal to 5a plus 5 times a negative 1 is negative 5. So I'm going to add 5 to both sides. I get 10 is equal to 5a. Divide by 5. A is equal to 2. Alright. Now I can plug in to find c. So a is 2 plus b is negative 1 plus c is equal to 6. So 2 minus 1 is 1 plus c is equal to 6. Subtract 1. I get c is equal to 5. I can write this in the order of a, b, c. So 2, negative 1, 5. Alright. Guys, hopefully you remember a little bit about solving those systems of equations. If not, this lesson may have been a little bit have some little bit of difficulty for you, but just practice that solving equations.